So yeah, okay. Second question. Where are the scripts? Have you already found that? So where are all these kind of magic tools that we are running here? Well, let's go back to the website. Find it. I think it might even say here. No, it doesn't. Okay, then let's search for it. We are in a Unix environment, so everything is in bin. So if you want to really dig deep, just look at what is here in bin. And there you find here your deploy thing. You find Cloud Commander start, Cloud Commander stop. You find this web starter that we just have used. You find here these MQTT listen scripts. Yeah, so that might be quite nice. If you look here at MQTT listen, there you see that in the end, this is still just running Mosquito sub. So it's just a little bit boilerplate, making it possible that it automatically derives the topic that you are working with. So it's a lot of convenience tools. You find something that it actually scans for the available USB ports. So in Arduino IDE, you always have to select which USB ports things are connected to. So there's a lot of convenience that you actually can find here. So and always, if it's not in the documentation, unfortunately, you have to start looking at the code. And so as a start, if you want to understand more about IoTempower, I suggest highly to look at the folder here. Now, there's one kind of cool thing that Caspar and I have recently worked on, which is actually this script access point. So and you can often turn an old computer also into an access point. So a lot of old Lenovos allow you to run in the Wi-Fi chip in access point mode. So if you want to set up a very simple IoTempower system, you can try to actually run the access point. It should pick up especially if it's connected via Ethernet, then you should be able to pick up the Wi-Fi device, and it will try to start actually an access point on the Wi-Fi device. Yeah, you can run them all the services like you do on the Pi. You can run all the services also on the old laptop. But I won't do this now because I accidentally forgot to switch off the Wi-Fi, and I think the video streaming might break if I'm doing that now. So I'm just telling you. You have seen several ways of accessing the documentation. But do you know where you can find the actual documentation? In the sources from IoTempower. Here, in doc. All documentation is in doc. But okay, you see here some kind of general documentation. So where do you find all the device documentation? Actually here in Node Help. So if you don't have any IoTempower running, you can actually go onto the web page and then look at the commands that are here. So we have here, for example, PWM somewhere, PWM. And then you see here is the same documentation you can also see if you go to the website. However, if you remember output, that it's the same as LED, and then you see here actually that here it's basically just a link that points to output. Yeah, so that is not as nice if you use the documentation basically vanilla in code than if do it here. So you can also, of course, find the documentation just in your sources. So I installed everything into IoT. And here you see basically maybe a hint for some of you. So I like the command line, but I don't like typing in CD all the time. So as you see, I'm using a lot this MC, which is the Midnight Commander. It's like the Norton Commander. You'll probably, maybe we have one person that might be old enough to still remember the Norton Commander, but it's basically a console-based file manager. So highly suggest you install Midnight. It's actually on the IoT gateway, so it comes pre-installed. But so we were talking about looking at the documentation, and you see it's also then here, of course, in doc. And I thought I could show you better that in Node Help, there are a lot of links. Yeah, you see, basically, these are all the duplicate commands that point at the source here. So we know where documentation is. Lib node type. Let's look at lib node types. We can kind of go online. Lib node types. So maybe kind of browse a little bit yourself and look there what this could be. I can also go use the Midnight Commander to go into lib node types. Here, lib node types. Why is this an important directory?
It shows all the microcontrollers that are supported.
Yeah, that is one of the things, but it doesn't only show them, but it also gives some functionality. So it has some semantics. It's not just a list of the microcontrollers that are supported, but if you kind of go here into the source of ESP, you see a lot of source code. Yeah. So what could this source code be for? So especially if you, for example, look at, let's say, output or so. See, there's an output H and an output CPP. And so if we open this, you kind of see a lot of C++ code here. So what is this code probably for? You see here, basically, you see these commands that you kind of know from the Arduino IDE. And where's the setting of the, and here you see a closure in C. And you see basically that this calls kind of a set function based on the payload you get. So what are these files for? These are the drivers that make it work. These are the wrappers that around the classic Arduino code that allow you to have just one command per file. So this is trying to take all the work away from you to make this accessible. Yeah, but okay, so you see, if I go in ESP and source, there's lots of stuff in here. So let's go into, for example, the Vemos D1 Mini. And you see there's not even a source folder in there, but there is a base that points at node MCU. So let's go into node MCU, and there's also a base that points at ESP8266. And there's a little bit of source. So you see kind of a pin, the pins are in the source file. So really important file. So the pins for the node MCU and Vemos D1 Mini are the same. And here you can kind of see all these definitions with D1, D0, clock, meso, mosi, and all this stuff. So this is basically the convenience macros for you to access the onboard GPIO ports. And so now if we kind of go all the way into ESP8266, you see that in the end, this looks at ESP itself, and there we finally are where all the sources are. So what kind of structure have we discovered here in these node types, just based on files? As you see, some kind of form of inheritance, kind of that things are always going to some terms of base. So if you also see even the ESP32 mini kit points to ESP32, and this base goes back to ESP. But the interesting thing is here in lib, you actually see that the ESP32 has its own PWM driver that is different from the PWM driver on the ESP8266. So it's kind of a hierarchy that allows me to combine these things. So if we go to our new IoT system that we built, and so I will kind of call this here our test 01 node. And okay, let's look at the nodes directly. So you see this key in here. And you see at the moment it has some kind of random garbage in this key. So, and then let's look at the setup. And let's just do something generic in here. And just say define an output blue LED built in. And here say it's inverted. And now let's call not deploy because I don't have a device connected or initialize serial. What I will call now, we'll just call compile. And I have to be in the IoT environment. So IoT and go to test 01. And here I'd call compile. Compile is basically just building the whole system without writing it either to the network or to the device. You see it's a little bit faster than on the Raspberry Pi. But you see it create, so first let's look at the key again. You see now there's random stuff in there. So do I use security? A tiny bit. So this is actually a symmetric key that is both here on the device and on the Vemos D1 Mini, and it protects the flashing. So only if you know this key, you can flash the Vemos device. So only with this key, you can make the update. So, but it also created this weird build thing here. So, and if you look in build, you see the source, and you see a lot of links to these kind of different files we just looked in the node types. So what IoTempower does for you, it creates this build folder, and there's a source and a lib in there, and a platform IO ini. And the cool thing is, now if I start Visual Studio Code, so we make a new window here. And in this new window, we will open this build folder. File, open recent, now open folder. And here we go into IoT systems. And then we go into the what did I do in class test 01, and here into build. If I open this folder, then Visual Studio Code actually detects that this is a platform IO configuration. And if you now want to do some better analysis of the code, if something goes wrong, you can actually open the setup.h here, which is linking to the setup CPP that we have done before. But basically, it gives you the full programming environment to do something more complex in editing your code. So you can copy the stuff to your computer and then work on the code if you create the build folder, and then you can edit the setup CPP if you do some more interesting things that things react locally. Okay. So basically, there is a bridge of using Platform IO to interact with IoTempower directly. That's what I wanted to show you. And all this kind of node types we had before help you in kind of packaging it correctly for your microcontroller. So let's set this. And then we have something more. I mentioned that to you guys. So if you want to switch to the ESP32 mini kit, you can basically do this in this node.conf. But you can actually also override other generic variables from IoTempower in the node.conf if you basically want to give different MQTT servers to different nodes. You can actually, like here, the variable we had in the system.conf. So basically, you can give different Wi-Fi networks to different nodes if I want to. So I can have a huge deployment over actually having different Wi-Fi networks. And then I can also give different MQTT hosts even per node.